In Chapter 3, we're going to look at the concept of vectors. In this first video, I want to look at the idea of the difference between vectors and scalars, and the two types of notations for vectors, polar notation and rectangular notation. And then we'll look at some examples of how we convert from polar to rectangular and from rectangular to polar. I'm actually going to break those into two separate videos so that you can easily find those examples if you want to go back and look at them. Vectors and scalars. We talked about this earlier in the course. A scalar is any quantity that only contains an amount. Some examples of scalar quantities are distance, speed, time, mass, things that have just an amount and do not contain a direction. There's no direction to time, there's no direction to mass. Speed is a quantity that only involves how fast you're going, not the direction. Distance, how far you've gone, not the direction. A vector is a quantity that contains both magnitude and direction. So the magnitude, how much, and the direction that it's traveling. The vector that corresponds to distance is displacement. The vector that corresponds to speed is velocity. Other quantities that we've worked with, acceleration. And later quantities that we'll work with, such as force, are all vector quantities. So these have both a direction and a magnitude, an amount. So displacement might be the number of meters at what direction. Velocity would be the meters per second at what direction. Acceleration, meters per second squared in a direction. Force, newtons, is the unit for force, in a direction. Now, how we go about specifying that direction depends on which type of notation we are using. There are two types of notation for vectors. One is known as polar notation, and one is known as rectangular notation. Polar notation defines a vector by its angle and its magnitude. So how long the vector is, the arrow that we draw, is the magnitude, and the angle is the direction. We need a common way to think about these angles, and the way we use is we always start from the positive x-axis and go counterclockwise, so the angles can be anywhere from 0 degrees to 360 degrees, going counterclockwise from the x-axis. So something going down the positive x-axis, going directly to the right, would be 0 degrees, and then the further we get away from the x-axis, going counterclockwise, would give us our angle. Let's look at some examples of this. If we have our coordinates, this being our y-axis, this being our x-axis. Going straight down the x-axis, this x-axis will be 0 degrees. We're going to always go counterclockwise. So up here would be 90 degrees. The negative x-axis would be 180 degrees. The negative y-axis would be 270 degrees. You can get all the way back to 0 or 360. So anything in this quadrant would be between 0 and 90 degrees. Anything in this quadrant would be between 90 and 180 degrees. Anything in the third quadrant would be between 180 and 270 degrees. And anything in the fourth quadrant would be between 270 and 360. So we're looking at four potential places where the angle can be. We always go counterclockwise from the positive x-axis, with the positive x-axis being 0 degrees. The other type of notation we do is to break vectors down into their components, which is what's happening on the x-axis and what's happening on the y-axis. So separating a vector down into just what's happening horizontally and just what's happening vertically. And we write it as a series of components. The x components is positive if it's to the right, negative if it's to the left. The y component shows how much it goes up or down, up if it's positive, down for negative. And we define it by its components, always writing the x component followed by the y component. So whereas the previous notation we had the magnitude at a direct angle, now we have the x and y components. So we think of this in terms of directions, our same axes. This will be our positive and negative for the x-axis. Positive to the right, negative to the left. Negative down, positive up. So this quadrant up here would have a positive, positive. This quadrant would be negative, positive, negative x, positive y. This quadrant would be negative x and negative y. And this quadrant would be positive x, negative y. So depending on which of those we are dealing with, we'll know which quadrant of the possible directions we are located in. So we have polar notation that works on magnitude and angle. We have rectangular notation that works on the two parts, the x component and the y component. In the next videos, we're going to look at some examples of how to convert from polar to rectangular and how to convert from rectangular to polar. And that's the main thing we want to get out of this chapter, knowing exactly what a vector is and how to convert between the two notations. So the next two videos, one will be polar to rectangular and one will be rectangular to polar, showing you examples of how to do these two conversions. And these are the only real problems we're going to do with vectors in this chapter, is how do you convert from one notation to the other and exactly knowing the definition and what the difference is between a vector and a scalar.